Hello, it's Duncan. I'm currently helping a less experienced developer, hi Connor, learn test-driven development. And this week we looked at the FizzBuzz kata. FizzBuzz is a really good introduction to TDD. Because there's really no complication to get bogged down in, we can focus on following the process. 1. Write a test that the production code doesn't pass. The test should show the smallest useful increment in behaviour towards our goal. 2. Change the production code to pass the test in the simplest way possible. 3. If necessary, refactor production code or tests, but not both at once, to improve their design while still passing the tests. 4. Repeat until done. This video adds an element I haven't seen from other FizzBuzzers, which is acceptance tests. Ideally, we'll write some sort of acceptance test before the main TDD cycle. They should be part of the specification we agree with the product owner, and when they pass, we know this story is done, barring any final refactoring. Plus, as a bonus feature, we'll look at how to output all the FizzBuzzes, or at least the first 2 to the 63 minus 1 of them, with, full disclosure, another accidental 2 to the 63 minus 1 negative ones. Is that a bug? It turns out even TDD doesn't guarantee software quality. And there we have it. I'm calling that the ultimate FizzBuzz. Hooray! This seems to be the canonical statement of FizzBuzz here on codingdojo.org. And it says, write a program that prints the numbers from 1 to 100. But for multiples of 3, print Fizz instead of the number, and for multiples of 5, print Buzz. For numbers which are multiples of 3 and 5, print FizzBuzz. Sample output, 1, 2, Fizz, 4, Buzz, Fizz, 7, 8, etc. All the way up to 100, although I can't help noticing that 100 actually shouldn't be 100, it should be Buzz. Now I have seen people TDD this who simply showed that they could generate a sequence that looked like this. But the spec is quite clear. It says write a program that prints the numbers. Now the only way to be sure is to do that from outside the program, but there is a little shortcut, so let's have a look at that. This is a completely empty project with Kotlin 2 and JUnit. Let's start by creating an acceptance test. So we'll say new Kotlin class file, and we're going to call this FizzBuzz acceptance tests. And we'll make that a class. And we will add it to Git. And now let's add a test method to that. We'll call it prints FizzBuzz 200, and we won't do anything for now. We'll just check that we can run all the tests. So we'll go here and we'll say run all tests, and from now on when I press Ctrl R, I will run all the tests that we've written. Now then, a little trick that we can use to write JVM acceptance test to test printing is that we can actually call system.stdout, and that will set a print stream that's used whenever we do println. So we need some sort of print stream. Let's create one of those, and we want to create a print stream, and you can see here we can create a print stream on an output stream, and IntelliJ is suggesting we create it on a byte array output stream. That's not a bad idea, because if we import this and then make this into its own thing, this is actually our output. Anything that's printed by the program once we've set this output stream will appear in this byte array output stream. So we can show that by saying println hello world. Now if I run this, you'll notice we haven't printed hello world, it's disappeared, and it's disappeared into this output. So we'll assert equals that hello world should be our output toString using UTF-8. So everything we printed to this print stream ended up in this byte array output stream, and the byte array output stream remembers what's been printed to it, and we can get that by toStringing it. Is that right? Oh no, why not? Let's have a look at the difference. Oh, and we just didn't account for the new line that we get because we did println. So if we take that and we say this should be hello world /n. True, splendid. Now then, there is a problem with this technique, which is that as soon as we apply it, we lose all the output that we might want to see if we were debugging, etc. So what we're going to do is we're going to remember the old print stream. So that is val old stdout is system out. Then we'll set the new one. We will do a thing. And then finally, we will restore it. So we'll say system set out old stdout. That should still pass and does. Now there's still a problem, which is that if we run tests in parallel and a test runs at the same time as this one, it will be writing into system out and make this test fail and everything go a bit wonky. But the fact is that acceptance tests are always a little bit flaky, and this isn't a bad compromise. In fact, if we make a little lambda out of this thing and call it in there, and make this thing into a variable, which we'll call stdout result or something. Then we can take this lambda here as a variable, move it out of here, and then all of this thing we could make into a nice little function. So let's make a method out of that. And IntelliJ has simply failed there, hasn't it? Because it has forgotten our function. Well, I'm going to go forward anyway. I'm going to say this is capturing stdout. I'm going to say we wanted to pass the function into that. That means we want to add a parameter like that, and we wanted to call that function in here. This wants to return not a string question mark, but a non-null string. We can inline that. Does it still work? It does. Does it fail like we expect? It does. And so now we can take this thing, and it's a nice little utility, so maybe I'll take it out of this test. Just put it at the top level for now. That lets me inline that, and then move that out of the parentheses. Good. And now I think we can simplify this a bit by inlining that, as we don't need it anywhere else, and then moving this into there like that. Good. I'm sure there are some circumstances where this being hard-coded to UTF-8 will be a problem, but we appear to be okay here. So then, now we have a way of running acceptance tests. What should that acceptance test do? The answer is it shouldn't print hello world, it should invoke main. We don't have one of those yet, so let's create one. Is that an option? No, just import. Okay, so let's go over here and we will say new Kotlin file class. We'll call it main, and we'll write ourselves a main. And then we'll go back to our acceptance tests and say, if we've run main, we don't expect this hello world thing, we expect something else. And that something else is 100 lines long and is, or at least begins with this. So let's take that bit and then go back. Let's remember those in a little val here. So we'll say val first lines equals, and we'll paste that into there. And now I think we could say assert true stdout result starts with not FizzBuzz but first lines. We need to import that from Kotlin test, and obviously that's not going to work, but let's just see what it says. Okay, it does fail, and it will fail because in fact we haven't printed anything, so I guess it will be the empty string. We could actually just check that, and it's right. Now then, I kind of want to avoid making this all the lines, but I'd also like something better than assert true. So I think what I'm going to say is that if we take our stdout result, get the lines out of it, and then take the first 20 of those, because we got up to 20 here, then we expect that to be equal to our first lines, if we converted that to lines. Now obviously this isn't going to work, but now we get a better comparison. We can see what we were expecting to get and what we actually got, which was empty. Just before we go on, this string is a bit irritating. Let's drop that down, put in a pipe there, and indent, and then say trim indent. Check that we're still the same. Oh, I'm an idiot. That should be trim margin. How are we? Good. Now normally in TDD we write the smallest test we can get passing, but of course acceptance tests aren't like that. Once this test passes, we're done. We don't want it failing until we're done though. So what we're going to do is we're going to go up here and just disable this test. So we're going to say @disabled, and here we can say not finished yet. So now if we run all the tests, that one won't pass. But when we think we're done, we can enable it and find out whether we are. Little tiny tidy up, we will optimize the imports, and I think probably make first lines private, run everything, and we're still passing no tests, and let's commit this as add FizzBuzz acceptance tests. Good. Okay then, so we've got an acceptance test. Now we're going to test drive the implementation of something that will eventually pass that. So let's go here and we'll say new Kotlin class, and this is going to be FizzBuzz tests. We'll move it back over here, and let's write our first unit test. It's going to be test, And now we have to think of the simplest functionality we could implement. Now, simple is in the eye of the beholder, but one thing that's going to make our tests not simple is if we have 100 lines of output every time. So for our tests, at least, I think we need to be able to control how many rounds of FizzBuzz we're doing. And if we're going to do that, then we can reduce it to a really simple round of no rounds. So I'm going to write a test that effectively says it is empty if we have no rounds. Now for unit tests, we don't want to be going and capturing stdout for our output. So we want a function that's not main. It doesn't print to the standard output, but instead return something. Now thinking it through, that something could be either a string, where we'd have multiple lines, or it could be a list of strings where each one of those is going to be a line in our output. On the whole, I prefer the second. So I'm going to say assert equals empty list of string is what we get if we call some function we don't have yet, giving it 0 rounds. Okay, let's at least pull in assert equals. And now if we go here, IntelliJ says, well, you could create this function FizzBuzz. So let's do that. And let's put it in here, call that rounds. You can see that it knows we need to return list of string in order to make this assertion work. And if I tab one more time, it'll put in a to do. That's good. Now, if I run all the tests, we should get a test for this one, and it should fail with our not implemented error. But we should be able to make it pass just by saying return empty list. Brilliant. Now then, we certainly don't want this function inside our test class. We could move it out there, but it's production code, so in fact I'm going to move it over into here. Having moved it, our tests can't see it. We could make it internal. That would be fine, or we can make it public. And I think I'd like it that our users could put in rounds other than 100, so public is fine. Let's run that. Good. Okay, before we go on, we started from the outside. We started from the acceptance tests and started working our way in. Well, we didn't actually work our way in, we just created a main. And now we started from the inside. We said, what sort of representation makes sense to our tests here? So the question is, how do we join the outside to the inside? And I think the answer is that our main needs to say FizzBuzz for 100 rounds, which is the spec. And then for each one of those, which is a string, we need to println the string. Now we've written that code without a test. We have got a test here, the acceptance test, but that will only pass when FizzBuzz works. This is, if you like, proof of concept that we can join our inside to our outside. Okay, so just reminding ourselves, we've got one test and it passes. We could tidy it up a little tiny bit there. So now we have the passing test. We've done a little bit of refactoring. We've added this in here. Let's add ourselves another test. So I'm going to take this thing and duplicate it. And now what's another simple thing I can do? I think I could just take the first couple of numbers. So I'm going to say is just numbers up to 2. So if I go up to 2, this is not an empty list. It's a list of something. Now what do we want in here? I think we decided strings. So this is going to be a list of 1 and 2. And that's what's going to happen if we ask for FizzBuzz with 2 rounds. I'm going to put these on separate lines so we can see it. And now we've added a test. We don't expect it to work, but we just check. Good. We want 1, 2, but we've got an empty list, and it's not surprising we've got an empty list because that's all we return. So now we go into the implementation stage. How do we get this test to pass? We could create an empty list of strings and then add things to it for every round. But for problems where we had the same number of things in an output as in an input, so this was 0 and we got 0 things, and this was 2 and we got 2 things, starting with a range and then mapping is our friend. So we build a range in Kotlin with the ... So we're going to go from 1 to the number of rounds. But we don't want for each, we want map. And if we map, then this is our round. Now that round is an int, but we want a list of strings, so we can just convert it to a string by saying round.toString. And now instead of returning an empty list, we're going to return that thing. Does that work? Wonderful. So now we've got our second test passing. What about our third test? Well, we've just done 2. 3 would seem to be a good one. So we can say in here, 3 is Fizz. So if we did FizzBuzz to 3, then we would want 1, 2, Fizz. Now we suspect that won't pass. And we can check that it doesn't pass in the way we expected, which is to say that we didn't replace the 3 with a Fizz. How do we replace the 3 with a Fizz? Well, I guess in here we can say if round equals 3, then the thing we want to map to is fizz, else it's whatever the round is to string. Put that there so we can see it, and run. Splendid. And note that I really have done the simplest thing. I haven't checked that it's divisible by 3, I've tested that it is 3. And the reason is that I haven't got a test to show that divisible by 3 is important. That will come in a minute, but let's go up to 5. So I duplicate that, say 5 is buzz. So if we went as high as 5, then we would get fizz, 4 in quotes, and buzz. Do we expect that to pass? No, we don't. Does it feel like we expected? Yes, it does. And how do we fix it? We could say else if, or we can say, let's make this into a when, and then we can duplicate that and say 5 goes to buzz. And our test passes. Okay then, what about 6? Well, 6 should be fizz. Let's duplicate this again. So 6 is fizz. I'll go up as far as 6. That should be fizz. This won't work. And now we could put 6 in here, but we know we'd be on hiding to nothing. So this is the point where we need to check that it's divisible by 3 and not just 3. So I think we can do that by saying, let us inline the when argument, like that. And then we can say when round mod 3 equals 0, then we do fizz. Brilliant. Now then, I'm quite lazy. And in order to see the next interesting thing, we'd have to do 10, and I'd have to type out 7, 8, 9, and 10 in here. And I really don't want to have to do that. So what I'm going to do is I'm going to take this thing and make a function out of it. And we are going to call that FizzBuzz4. And if I make that internal, that's the thing I can test from the other side, from the tests. So we'll just check that hasn't broken anything. And it hasn't. And now I can start writing tests like this. I can say 10 is buzz. And I can say assert equals buzz is FizzBuzz4 10. Is that true? No. Oh, that was the point, wasn't it? Because I wanted to make this into mod 5 equals 0. Good. So the desire to make our tests a bit simpler has helped us see that pulling this thing out would be nice. Note that the signature of this and this is kind of the same, but this parameter is different. This is the total number of rounds. This is the actual round we're in. I think if we make this a receiver, then we could call this to FizzBuzz and just demonstrate that that returns a string. Sweet. So now I think I might return to our tests and say, it's fine going up as far as 5, but after that, let's start using toFizzBuzz. So now we can say divisible by 3 is fizz, and we can just make simple assertions to say assert equals fizz 3 to FizzBuzz, and the same is true for 6, and the same is true for 9. And now we can do the same thing for buzz, so we can say divisible by 10 by 5 is buzz, and we'll take 5 and 10. Good. 15 though is another special case. We should also have divisible by 15 is FizzBuzz, and so if we try 15 and we try 30, that should be FizzBuzz. We don't have the code for that, so we've come out of refactoring and into creating a test that fails. And it does the way we expect because we get fizz and not FizzBuzz. And we can fix that by saying this mod 15 is FizzBuzz. Great. So now we have a set of tests. The top ones show list operations. And then once we get a bit long, we start looking at just the individual numbers. So the question is now, do our acceptance tests pass? We take that out. So now I should ask myself, what chance do I think there is that this will pass? And the answer is, well, maybe only 50-50 because of line endings. We may have a blank line at the end of this or what, I don't know. Let's run and find out. Oh, so close. Let's see what the difference is. And the answer is that we seem to have an empty item at the end of the things we were expecting. I think that's probably that bit there. Let's find out. Good. Now then, we're still only looking at the first 20 lines. We could either paste the actual output in here for all the other lines, or maybe more pragmatically, let's take this thing into a variable and start asserting more things about it. So I think we could say that the first lines are like that. That's good. And we could also say that lines size should be 100. Oh, why is that? Well, I suspect that because we've got 100 things here and we println for each one, we've got an extra blank line on the end. So I think we'll find that there are 101 lines, and that lines last is an empty string. Let's find out. Good. And that the one before that we predict should be buzz because it's divisible by 5. So that's lines drop the first 100. Or maybe 99, who knows. I'm going to take a punt on 99. We want the first one of those. Hooray! So I think really that means that lines get 99 is our buzz, and that lines get 100 is the empty string. Wonderful. So you can see what we've done is we've written a single acceptance test that shows the wiring up of main in terms of something we can test more easily, this FizzBuzz. And then the thing we can test more easily, this FizzBuzz that takes a number of rounds, we've made unit tests for. So I think that's pretty done. We can just make this into a single expression body like that. Check everything so passes. Pretty good. And let's commit that as working FizzBuzz. One thing to look at. Let's have a look. Unused import. Oh dear. Let's fix that and amend that. So are we done? Well, we certainly could be, but one thing I'd like to revisit is the return type of this FizzBuzz. At the moment it's a list of string. That makes our test really easy because we just create lists in here that we can compare. However, let's say we're really serious about FizzBuzz. Let's say we want to see all of the FizzBuzzes. So we'll put in here int max value. So let's run that. Now we're having to build a list with 2 billion elements in it. And we're having to do that before we can print anything because this needs to return a list of string. So we're not getting interim results. Well, that may be okay. I'm prepared to wait. Oh, so what happened there? Well, you probably predicted we ran out of memory. We don't actually have enough memory to have this list of 2 billion strings. So if we're really serious, we've got to do something else. And that thing is to use not a list, but a sequence. Now, in order to do this, I'm going to return this back to 100 so that we can run our tests. And what we need is not a list here that we then map, but we need a sequence of 1 to rounds. So that will be val sequence is, and actually generate sequence it plus 1 is pretty good, but I think we want to start at 1. We've also got a problem that this needs to be a block body until we're done. So we're going to return that. So now we've got a sequence, we could use it instead of this range here. So if we take that and put it into there, the compile problem now is that we've got a sequence of string but wanted a list, but we can just two lists on a sequence. But now notice that rounds is unused. And that's because this sequence is unbounded. It'll go on forever. So what we need to do is we need to take the first rounds of them. Let's see if that passes our tests. Oh, that was just main. Let's try all of our tests. Good. And now I'm going to rearrange this function a bit. I'm going to say that I want to take this bit into a variable and then inline this bit. And now this thing we can extract a separate function for. So this is going to be FizzBuzz sequence. And let's remind ourselves that that's going to return a sequence of string. And it's going to start with a sequence from 1 forever, pretty much. And then those numbers are going to be the round, and we're going to convert that round into a fizz or a FizzBuzz or a number. That, then we can inline there. That we can make an expression body again. And so now we've defined the version that takes rounds and returns a list of string in terms of a version that returns an infinite sequence where we can stop taking from that sequence when we have enough. I don't know whether generate slipped in there. I think we're just going to call this FizzBuzz sequence. And I think that might as well be public as well. And now if we're really serious, we can use FizzBuzz sequence with no bound. There's still a for each on sequence as there is on iterable. So now if we run this, not only do we get results out as they appear, but we're not going to run out of memory. I could sit and watch this all day, but I won't. If we're really, really serious, then we can generate a sequence on a long. In order to do that, we'd need a version of this that was long to FizzBuzz. And here we'd have to keep on putting some L's in. And even on this side, irritatingly. But if we went that far, we wouldn't be restricted by a mere 2 billion rounds of FizzBuzz. We could go all the way up to whatever that number is. Irritatingly, we can't just delete this because we lose the ability to compile here and we'd have to put in L's, which is a pain. But maybe we could keep this and define it in terms of the long version. So this would be this to long to FizzBuzz. That would keep our test compiling and passing. This would go on for practically ever. But if we return this to FizzBuzz on 100, then all our tests pass. It might be interesting to benchmark, see whether working in terms of ints is quicker than working in terms of longs, and also see whether working directly with lists is quicker than using a sequence and then taking a certain number. But it's a very hot day here in England, and I don't want my processor to make it even worse. I think maybe we could say that this little thing here is now just used by our tests. So put that there, make it private, and there we have it. I'm calling that the ultimate FizzBuzz. Hooray! Finish up by committing with use sequences. And I think, most unlike me, that this will stand on its own and not be a whole series. I do have a lot of series of videos though, and ideas for new ones. So if you'd like to see those, then please subscribe to the channel, like this to help other people find it. And you could support my work by buying a copy of the book that I wrote with that price called Java to Kotlin and Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.